Hello everyone. Today we're talking about transformations of exponential and logarithmic functions. Please remember folks that our rules for transformations are going to be the same as what we've been using since we started transformations in October. The only thing that's changing really are the parent functions that we're applying our transformations to. So let's take a look at number 1. F of x is equal to 3 to the x. It wants to give the table for the parent function that's listed. So, if you might recall, we use 5 points for our table. Always the same 5 points have to show up on our table. Usually, we put them under the x. -2, -1, 0, 1, and 2. So, 3 to the -2. This means when we have a negative exponent, we take whatever number we have and we flip it basically. So 3 to the -2 would give us 1 over 9. 3 to the -1 would give us 1 over 3. 3 to the 0, any number to the 0 is 1. Then we have 3 to the first power. Any number to the first power is itself. Then finally, 3 to the 2, or 3 squared, gives us 9. Moving right along. Number 2, we have the e value. And e, as you may recall, is an irrational number. But for our purposes right now, we're going to approximate that e into 2.71 to make our math a little easier. We're still going to use those same 5 numbers though. We're still going to have our -2, -1, 0, 1, and 2. Well, e to the -2, you can use your calculator for this, should give you approximately 0.13. E to the -1, 0.37 from your calculator. Any number raised to the 0th power, well, that's going to give us 1. Any number raised to the first power itself, so approximately 2.71. And then that 2, e squared, by our calculator should give us 7.39. Moving right along. Number 3. This time we have a fraction being raised to an exponent. We're still going to have our same 5 points. -2, -1, 0, 1, and 2. And remember folks, when we have a negative exponent, it's going to flip our base, taking the reciprocal. So the reciprocal of 1/5 is 5. So 1/5 to the -2 is the same as 5 squared, which is 25. By that same token, 1/5 to -1 is 5. 1/5 to the 0, any number raised to the 0 is going to be 1. 1/5 to the first power, any number raised to the first power is going to be equal to itself. And then 1/5 squared, well, that's going to give us 1 over 25. Moving right along, we get to number 4, 5, and 6. Now note folks, in 4, 5, and 6, we are now dealing with logarithms. Logarithms, as you may recall, are going to be the inverses of our exponents. And so, to help make these problems a little easier, we're going to change up what we've been doing slightly. We're going to take this logarithm, we're going to set it equal to y, so we can convert it into an exponent, which will give us, based on our rule, the first number to the power of the last number equals the middle number. So the first number here is 3 raised to the last number, y, is equal to our middle number, x. We set up our table, x and y. Now here's where we're going to do things a little differently. We're still going to use -2, -1, 0, 1, and 2. However, we're not going to put them into our x value, because now our equation here, number 4, is the inverse of number 1. So, instead of the x area, we're going to put them in the inverse of x, the y area. So we're going to have under that y, -2, -1, 0, 1, and 2. Well, 3 to the -2, that's going to give us 1/9. 3 to the -1, that'll give us 1/3. 3 to the 0 will give us 1. 3 to the first will give us 3. 3 squared will give us 9. If we take a look, number 4 and number 1, our tables are inverses of each other. They are flipped mirrorly against each other. What was x's in number 1 is now y's in number 2. What was y in number 1 is now x in number 4. So, with that in mind, let's move on to number 5, natural log of x. Now the natural log of x, as you might recall, is the inverse of e to the x. So we're going to do a very similar thing we did here as we did in number 4 and number 2. We're going to put our equals y. To rewrite this as e to the y is equal to x. We're going to make our table, our x and our y. But we're going to put, just like we did number 4, our -2, -1, 0, 1, and 2 in our y column. So our x has become what was previously our y's in number 2. 0.13, 0.37, 1, 2.71, 7.39. All right. Number 6. Now note, folks, number 6, we don't have an exact inverse. In number 3, we had 1/5 x. In number 6, we have 1/4 and the x. So it's not going to be identical, but it is going to be similar. So same sort of process. We're going to take our equation and set that equal to y. We're going to use our rules. Our first term, 1/4, raised to our last term, y, is equal to our middle term, x. We're going to set up our table, x and y. We're going to put in our y column the -2, the -1, the 0, the 1, and the 2. For our x's, well, looking at our translated equation, 1/4 to the -2 would give us 16. 1/4 to the -1, 4. 1/4 to the 0, 1. 1/4 to the first, 1/4, and 1/4 squared, 1/16. All right, so now we've done our basic tables, which means now it's time to move on to 7 and 8. Describe the transformation of function f represented by g. Graph each function and asymptote, then give the domain and range. Folks, I know some of you love this, I know some of you hate this, but we need to go through it together. So, number 7. F of x is equal to 1/3 x. G of x is equal to 2 times 1/3 raised to the minus x minus 1 plus 5. So, let's break this down. First things first, we've got this 2 out front. And that 2 means we have a vertical stretch of how much? 2. Looking on, we have a 1/3, but that 1/3 is the same as our parent function over here. So we're going to leave it alone. That 1/3 is not going to affect anything for us. However, next up we have our exponents, and we have that negative in front of that x. That negative on the x means we're going to reflect over the y. Then we've got that -1. And I know, folks, normally you're thinking, okay, -1, the x's lied to us. That means it's going to be right 1, except it's not going to be. This is where we need to use our zero insertion principle. We're going to take that entire exponent, negative x minus 1, and set it equal to 0, and solve for x. Negative x equals 1, x equals negative 1. So the entire exponent is actually moving the graph 1 unit to the left. So left 1. And at the end we've got that plus 5. Well, plus 5 means up 5 units. So now it's time to make our tables, which we're then going to use to graph. So our first table is always going to be our parent function table. So we've got our x's and our y's. Our parent function here, it's based off 1/3 to the x. So we've got our -2, -1, 0, 1, and 2. 1/3 to the -2 is going to give us 9. 1/3 to the -1, 3. 1/3 to the 0, 1. 1/3 to the 1, 1/3. 1/3 squared, 1/9. Our second table. Our second table deals with our multiplication and division. Well, we're reflecting this over the y-axis, which means our x values are being multiplied by -1. And we also have a vertical stretch of 2. That means our y values are being multiplied by 2. Going to take a look at our previous table. Our minus x is going to be negative whatever this column was. Our 2y is going to be twice whatever this was. So, -2 times -1, 2. -1 times -1, 1. 0 times -1, 0. 1 times -1, -1. 2 times -1, -2. 9 times 2, 9. 3 times 2, 6. 1 times 2, 2. 1/3 times 2, 2/3. 1/9 times 2, 2/9. Finally, our last table deals with our additions and subtractions. We're going left 1. That means x minus 1. We're going up 5. That means y plus 5. So we have, I just caught an error I made. Sorry about that, folks. That's supposed to be an 18 right there. My bad. So, moving right along. X minus 1 from the previous column. Our new column of x's is going to give us 1, 0, -1, -2, -3. Y plus 5, 23, 11, 7, 5 2/3, which is, for our purposes, approximately 6. 2/9 plus 5, 5 2/9, which is approximately 5. Now folks, I know that 5 2/3 is not equal to 6, and I know that 5 2/9 is not equal to 5, approximately because our graph tables are only so big. So we're going to have to approximate a little bit to make our lines clear. So let's take a look. When I graph the parent function, our first term, our first number, our first point is -2, 9. So x equals -2, y equals 9. Approximately there. Let's make that a little bigger. Okay. -1, 3. -1, 1, 2, 3. 0, 1. 1 1/3, which is close to 0. 2 1/9, close to 0. So you should see, folks, that we have a line that goes something like that. It does not cross or touch y equals 0. That's our asymptote of our parent function, y equals 0. And when we take a look at this for our new function, our translate function, our first term, our first coordinate, 1 and 23. 23 is not going to fit, so move on to the next one. 0 and 11. That's also not going to fit, but if it did, it would be somewhere up there. -1, 7. So -1, up 7, 6, 7. -2 and approximately 6. -3 and approximately 5. Note, folks, that this one does not cross y equals 5. That's our asymptote. Also note, up 5, that became our asymptote. I might have misspelled that, but you guys know what I mean. With our graphs done, it's now time to look at our domain and range. So, our domain of our new function. Well, if we look at our graph, our domain runs from -infinity until infinity. But the range, it does not seem to go below 5, but it does extend all the way up to infinity. As such, moving right along. Number 8. Here we've got logarithms. So to make this a little easier, we're going to rewrite our parent function as an exponent to give us, instead of log base 2 of x equals f of x, or y, to give us 2 to the y is equal to x. That'll help us later on when we make our tables. So, looking at our g of x, let's talk about what's happening. First up, we've got this minus sign out front. That minus sign out front indicates that we have a reflection over the x, what's that? That's t. Reflect over x axis. the log base 2 is the same as it is in the parent function. So we next look, we have that 1/2 x. Now that 1/2 is inside those parentheses. The parentheses are aligned to us. So that 1/2 is actually going to be a horizontal stretch of whatever 1/2 reciprocal is, 2. All right. Next up we have that -2. And once more, folks, I know some of you are thinking, okay, -2, that means we've got right 2 units. But folks, we have to remember our zero insertion principle. So we're going to take that parentheses there, we're going to set it equal to 0. 1/2 x minus 2 equals 0. 1/2 x equals 2. X equals 4. That -2, because of the 1/2 on that x, is actually a right 4 units. And finally, the very end there, +1. Up 1. All right, so translation's done. It's time to make our tables. And this is where that 2 to the y equals x is going to be helpful for us. So we set up our table. Our first parent function, we've got our x and our y, but because we're using the inverse exponents, or the logs, we're going to put those -2, -1, 0, 1, and 2 in the y column. So we can use our inverse functions to solve for our x's. And that'll give us 1/4, 1/2, 1, 2, and 4. After our parent function setup, we have our multiplication division. Well, we have a horizontal stretch of 2, so 2 on the x, and we're flipping this over the x-axis, so that's a negative on that y. We're going to use our previous columns for this. 2 times x, so 2 times 1/4 is the same as 1/2. 2 times 1/2, the same as 1. 2 times 2 times 1 is 2. 2 times 2, 4. 2 times 4, 8. And all this while, folks, all I'm doing is I'm taking this 2x, I'm plugging in this column of x's for this x here. Okay? Negative y, same sort of thing. I'm taking this negative y, I'm taking this negative y, I'm plugging in for the y's that were over here. So, that -2 becomes a 2, that -1 becomes a 1, that 0 is still a 0, that 1 becomes a -1, that 2 becomes a -2. And our last column, our last tables, well, those are our addition subtraction tables. We have right 4 units. So we have x plus 4, and we have up 1, y plus 1. So x plus 4 from the previous table, that's going to give us 4.5, 5, 6, 8, and 12. Meanwhile, in our y column, it's going to be y plus 1, so that's going to give us 3, 2, 1, 0, -1. All right, so you got our parent function. We have our fully translated functions as well. Time to graph it. So, you're in green, or teal, or Gumby color, for those of you who know the reference. Our first point is going to be 1/4 x and minus 2 for the y. So 1/4 and minus 2, about there. 1/2 and minus 1, about there. 1 and 0. 2 and 1. 4 and 2. So this line becomes something like this. Note here, folks, that previously when we had our equations, our asymptotes were at y equals a number. Now for our logarithms, this exponent here is going to be x is equal to 0. This parent function will never cross x equals 0. Now, let's take a look at our new function. Our first point, 4.5 and 3. So x equals 4.5, 1, 2, 3. X equals 5. It's going to give us 2. X equals 6, 1. X equals 8, 0. X equals 12 minus 1. Well, it's not really on here, but if it were, it would be about there between the R and the A for range. Now, we're going to draw our line. We should see is that this time the asymptote has moved to x is equal to 4, just like we have a shift right 4 units. Our new domain is 0, infinity. Our new range, negative infinity, infinity. All right, folks, so we've taken equations and turned them into sample tables. We've taken equations, turned them into words, turned the words into sample tables, and turned those sample tables into graphs. And now we're going to the last part. We're going to take our words from these sentences, we're going to turn them into equations. Now, folks, remember, we read from left to right, which means we have to make our transformations from left to right. So here, number 9, we're starting off with the parent function of 2/3 to the x. We're going to reflect this over the y-axis. That means we're going to replace the x values with a negative x. So that will give us 2/3 to the negative x. We then want to do a vertical stretch by a factor of 6. Well, vertical stretch by a factor of 6 means we're going to take whatever we had, we're going to multiply all of it by 6. A translation of 4 units to the left. Well, 4 units to the left, that means we're going to replace our x value with x plus 4. So that's going to look like we have our 6 from before, we've got our 2/3 from before. Now our exponent, we've got that minus sign, we're replacing the x with x plus 4. Now note, folks, that minus sign is going to distribute to give us 6, 2 to the third, negative x minus 4. I'm going to end this up with a 2 up and say plus 2. Now folks, I have the luxury of having this on a smartboard, so I can change up my zoom in if I need to, but if you're concerned about keeping your exponents away from your other numbers, you are welcome to put in parentheses as well to keep them separate. You don't have to necessarily, but if you'd like to keep your notes or your work cleaner, you're welcome to do so. Number 10. Now we're dealing with e to the x. We want to translate this 4 units to the right. Well, 4 units to the right means we're going to replace our x with x minus 4, because the x's lie to us. So we have e to the x minus 4. We're going to then take this and go 1 unit down. 1 unit down, toss a minus 1 onto it. Then we're going to follow that up with a vertical compression by a factor of 1/3. Vertical compression, factor of 1/3. Which means we're going to take the entire thing and multiply it by 1/3. So that will give us 1/3 e to the x minus 4 minus 1/3, because we have to distribute that 1/3. And finally, a horizontal stretch of 2. Horizontal stretch of 2 means that we're going to replace our x value with 1/2 x, because our x's are going to lie to us. So we have, as our final answer, 1/3 e to the 1/2 x minus 4 minus 1/3. And again, if you want to keep them separate, the exponents, you can put some parentheses on that. Number 11. Now we're dealing with logarithms. And folks, don't worry, they're not that scary. Reflection in the x-axis or across the x-axis. Well, reflection across the x-axis means we're going to have a negative sign out front. So instead of log base 2 of x, we're going to have negative log base 2 of x. Horizontal compression of 1/3. Well, horizontal compression of 1/3 means we're going to replace the x value with 3x. So we've got our minus log base 2. But instead of x, we now have 3x. Followed by translation 9 units to the right. So 9 units to the right. That means we're going to replace our x with x minus 9. Now folks, because we've already applied the horizontal compression, this means we're going to have to distribute that 3 across both the new x and the new minus 9. So what that's going to look like is we're going to have our negative log base 2 of our 3x minus 27. And the last thing we want here is to have up 4, or 4 up, which means we're going to have a nice little plus 4 at the end here. Finally, number 12, the last one of our set. We have a natural log that we're going to translate. We're going to take that natural log, we're going to move it up 3 units to the right. 3 units to the right means we're going to replace our x with x minus 3. So we're going to have the natural log of x minus 3. We're going to follow this with a vertical stretch. Sorry, with up 1 unit. Sorry, folks. A little tired. It's rather late right now at night, but you're going to see this in the morning, hopefully. 1 unit up, so plus 1. Followed by a vertical stretch by a factor of 8. Now, a vertical stretch by a factor of 8 means we're going to multiply everything here by 8. Remember that 8 is going to need to distribute. So we're going to have 8 natural log of x minus 3 plus 8. And the last thing we need is going to be a reflection across the x-axis. Now, that reflection across the x-axis means that we're going to replace the x with a minus x. Thankfully, it's a really quick fix here. That x gets replaced by minus x, so we stick a minus sign right there. And there we have our final translation.